Okay, so let's move on to the next part of these 50 NumPy functions needed for data science. We've already done 26 of them. We ended with the clip function here. And as I'm saying these and notating them, go ahead and say them aloud to yourself. If I say clip, you say clip. If I say where, you say where. Get used to saying these in your head or out loud so that you can actually communicate this stuff to the people on your team. Where returns the elements from an array where a condition is satisfied. So that if it's true, yield a value. If it's not true, otherwise yield another value. You'll see a good example here. Put. Now this put seems like it should be called replace, but it replaces a specified element of an array with given values. I think because it's operating on arrays, they're using the slightly different version of replace put. So just think, if I say put, you say put, followed by replacing elements in an array. Next up is copy to. Similar to the put function, but it actually copies the content of one array into another. So copy is literally copy. So we have that two functions here, copy and put. Similar. Okay, so let's actually, we might have some extra space here. I'm going to move this put up here since they're relatively similar. And we'll move on to set operations. So you'll find that there's probably 4 set operations. In set theory, there's the 4 primary ones: the intersection, the difference, the unique on the left or right, and the union. So let's see what's here. We have the intersect ID, returns all the unique values from both arrays, sorted. So you have 2 arrays. What values are unique to those arrays? And then you have difference. In this case, we have set diff ID, returns all the unique elements from array 1 that are not in array 2. So these are comparison. I have a collection on the left, a collection on the right. What is similar, what is not similar. The next one, set XOR ID. A function that returns all the unique values from both arrays in a sorted order. So the unique values from both arrays, sorted. And the final one is union. Union, and they put the ID on these, each one of these. Union ID. I wonder if these are 1D. Sounds like a 1 to you? Might be 1D. Perhaps there's some 2D elements that are not used as much. Perhaps that's 1D. Intersect 1 dimension, difference 1 dimension, set XOR 1 dimension, or union 1 dimension. I bet you it's 1 dimension. Yeah. All right, next one here is splitting. If you need to do a horizontal split, or if you need to do a vertical split. What does split mean? It just separates the data horizontally into your decided number of parts. So if you want to split it into 2, split it into 2. If you want to split it into 3, split it into 3. And then this is slightly different where it splits the data vertically into n number of parts. Useful for matrices. We have a couple of stacking functions here. We have a horizontal stack. We have a vertical stack. And stack would be append. You're appending one array at the end of another. So you're adding two things together. Or you can vertically stack one on top of another. In this case, it's going to add that comma between them. Some more array functions here. We have all close. Not all close, all close. Was it close or is it not close? It's a function that finds whether two arrays are equal or approximate based on some tolerance value. So you have to give the tolerance value. In this case, this author chooses 0.1. Equal. Comparing each element of both arrays and if the elements are equal. So not close, not approximate, but exactly equal. All right, here's some repeating function. So dot repeat. It is used to repeat elements of an array for n number of times. So do you want to repeat something once, twice, 10, 100 times? You can see that this author chose to repeat it 3 times. Remember, I say repeat, you say repeat. Tile. They group these together, tile and repeat. So let's actually keep that here. Tile and repeat. Constructs an array by repeating the number of times given by the reps. How many times do you want to repeat it? Repetitions. And what are you repeating? The prior parameter. So you'll see the repeat and the tile. Now here's a einsum. And if you haven't heard of eigenvalues, it's another advanced math concept, but this particular einsum is used to compute the many-dimensional and linear algebraic operations on an array. So if you have multi-dimensional arrays, or you have some type of linear algebraic need, think of the einsum. All right, so now we're moving into statistics. So how do you want to visualize your data? In this case, do you plan on visualizing it with a histogram? Computes histograms from your sets of data. Do you want to compute a quantile, qth percentile of the data along a certain axis? So we'd use the percentile function. And then you have your standard deviation and your variance, which those are always going to be grouped together because they're very related. If you don't know the difference between them, I would definitely look that up. Slight difference, and they're used for different purposes, but they're always kind of go hand in hand. All right, looks like there's 3 array printing functions. Print, set print options. We have set print options, which shows floats with 2 decimal places. In this case, they set the precision as 2. Prints an array to its max. So this set print options with a threshold, set print options with line width. So these are all set print options. So this is all one method. But what do you want to show? And what parameters do you want to use? Do you want to use the precision, the threshold, or the line width with the set print options? So interview question, what's the function to print? Somebody might say print, but a more advanced Python guy or gal might say set print options. All right, so what about saving and loading the actual data? Well, we have the save txt function, which is used to save the content of an array inside a text file. And then we have a load text function, which is used to load the content of an array from a text file. So you have this text file. I want to write to the text file, or I want to read from the text file. Save and load. I say save and load. You say save and load. Okay, so that looks like the total of all of these. He's calling them 50, but really there's a few less than 50. So let's do a little bit of grouping, and then we'll be done with this particular topic. So we have save and load, kind of set print options, doing its own thing. We have the statistical concepts here. We have things you can do with arrays. We have the set theory, 4 set theory functions. We have repeating and tiling. We have replacing or putting a copy into. We have this unique one, einsum. We have where, clips, rounds, absolute values, sorts, args. There's 3 of these args, so we can kind of group them together. Minimum, maximum, unique, mean, median, digitize, reshape. These are kind of different, so let's move these over. There we go. Then we have zeros, ones, full, count non-zero, and a bunch of random generation tools. So let's go ahead and move these up here. Alright, so let's make this a little bit prettier, and then now you can be more familiar with some of these numerical Python functions. Good to start your data science journey, or just to recap if you weren't aware of some of these. All right, so let's see how many we have here. We have 2, 4, 6. Let me pull up here. So if you've skipped ahead, you can see kind of what we're working on. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52. So now you have 52 NumPy functions ready to go.